Okay, now come to the today class. So any doubts from the previous class? No? No more? Okay. Now just so in this session I will give the brief overview of the total vector differentiation. Is it audible?
Yes, sir.
Okay.
Audible, sir.
So vector differentiation. So vector differentiation is related to the del operator. We know that del operator. Del operator is I dou by dou x plus j dou by dou y plus k dou by dou z. So here according to the previously we have the two types of functions. What is the first function? Two types of function. One is the vector point function, other one is scalar point function. Okay, so first of all I am taking here the vector point function. So f is f1I plus f2j plus f3k is I am assuming the vector point function. Vector point function. So in this vector point function again we have the two types of operations. What are the operations we have here? What are the operations?
Divergence and curl.
Divergent of a function f. Divergent of f. Divergence of f. Symbolically we will write. Next one is the curl of vector f. Curl of f. Now the come to the first one. The divergent of f. We will write the div f, or symbolically we will write the div dot f. This is the vector field, and the calculation is the I into dou by dou x plus j into dou by dou y plus k into dou by dou z into f1I plus f2j plus f3k. That is the dot product of these two vectors must be the scalar only. So dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. And moreover in this one, so if suppose if the divergent of the vector f is 0, what we call this vector?
Solenoidal vector.
So is called as a solenoidal vector. Solenoidal vector. Okay, so this one related to the divergent of vector field. Next one come to the curl. So curl of the vector f is, so symbolically we will write the del cross f, and the mathematically we will write it is the dot product of the curl of. So curl f is equal to, we will write the del cross f, and the mathematical just we have to find the determinant of the 3 by 3 matrix. So first row is ijk, second row is dou by dou x, dou by dou y, dou by dou z, and third row is f1, f2, f3. After simplification, what is the result? I into dou f3 by dou y minus dou f2 by dou z plus minus j into minus j into dou f3 by dou x minus dou f1 by dou z plus k into dou f2 by dou x minus dou f3 by dou f ఒక్క నిమిషం dou f2 by now dou f1 by dou y. Okay, so from this one just we are getting the necessary and sufficient condition for the exact differential equation for the three variables. Am I correct? Because it is 0, definitely it is totally. Next one, in this one also we have statement if suppose the curl of f is 0, what about the corresponding vector? Then that vector we call as irrotational vector. Very good. So it is irrotational vector. So irrotational vector. So it is under vector point function. Next one, come to the one more scalar point function. So here I am assuming the pi is a scalar point function. So scalar point function letters కనబడుతున్నాయండి. Scalar point function. Now so here we have the operation. What are the operation we have? Same related to the del operator. Now del pi. So what is here del pi? So del pi and so here we will write the gradient of pi. So gradient of pi, and we will write the grade pi also we will write, and mathematically we will write the del pi, and calculation is I into dou by dou x plus j into dou by dou y plus k into dou by dou z into pi. That means I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So this is the calculation of the ఒక్క నిమిషం. So calculation of the gradient of pi. So gradient of pi, and here we have some calculations. Normal vector. So normal vector is, we will write symbolically n, and just find the gradient of pi. So it is the normal vector or del pi. Next one, second one is unit normal vector. Unit normal vector n cap is gradient of pi by mod gradient of pi, or del pi by mod del pi only. Next one, third one is the directional derivatives. In the direction a vector is, what is the result here? The gradient of pi dot a cap. Okay, so now this is the directional derivatives of pi. Okay, and what is the previous one? The previous topic is the previous scalar potential field. So scalar potential field is related to the scalar potential field is related to the vector point function and scalar point function. That means just join these two. Join these two. That means if suppose this f is equal the gradient of pi, if f is equal gradient of pi, then what we call this pi is called as scalar potential of f. And here we have the few properties. What are the properties we have here? What is the first property? First one, f must be is equal to gradient of pi. And second property, what is second property? Here I am assuming f is equal to, okay, already f is, so f is equal to f1i plus f2j plus f3k. Now what is the result here? So here f must be the irrotational vector. This is the second point. And what is the third point? f1 dx plus f2 dy plus f3 dz is equal to 0 is an exact differential equation. And the one more point here, f1 dx plus f2 dy plus f3 dz is equal to d pi. And the next point is f1 dx plus f2 dy plus f3 dz is equal to 0 is exact differential equation. Definitely the curl f must be 0. And the next point, f1 dx plus f2 dy plus f3 dz is equal to 0, exact differential equation. The necessary and sufficient condition for this exact differential equation is dou f1 by dou z is equal to dou f3 by dou x, and dou f1 by dou y is equal to dou f2 by dou x, and dou f2 by dou z is equal to dou f3 by dou y. So this is the necessary and sufficient condition for this exact differential equation. Okay, if it is scalar potential field. Okay, Nandi? Just this is the overview of the vector differentiation. Inka formulas unnayandi indulo CRs, C1, C2, C3, C4 CRs. So this is the overview of total. Inka unnayandi? ఒక పేజీలో వర్కౌట్ అవుతుందండి, సింగిల్ పేజ్లో. హలో, ఓకే. ఇంకా ఫార్ములాస్ ఉన్నాయి ఇందులో మనకి వెక్టర్ డిఫరెన్షియేషన్లో. గ్రేడియంట్ అండ్ కర్ల్, నెక్స్ట్ వన్ డైవర్జెంట్ ఆఫ్ వెక్టర్ అండ్ scalar potential field. Scalar potential field. Scalar potential. No? Okay. So now what is time now? ఇంకా క్లాస్ ఉందండి ఏమైనా?
No, sir.
ఓకే ఈరోజు ఏం క్లాసెస్ లేవు. ఓకే సో నౌ I will stop now. So in the next class we will start vector integrations. Vector integration. So first of all we will discuss line integral, surface integral, volume integral plus three theorems: Green's theorem, Stokes theorem and Gauss theorem. Okay, so I think that next vector integration we will complete within 6 classes. I think in the first class we will introduce the line integral, second class double integral, and third class we will introduce the volume integral, and the fourth class Green's theorem, fifth class Stokes theorem, and in the last class Gauss divergence theorem. Okay, so that is the coming next plan. Okay, so anyway I will stop now. Thank you to all. సో అటెండెన్స్ ఇచ్చారా అండి? ఆన్లైన్లో అటెండెన్స్ ఇచ్చారా?